Welcome to the Virtual World Project. My name is Ray McLean, President of Third Dimension Technologies. What we'd like to do is show you a quick demonstration of 3D Expres. Before we actually demonstrate 3D Expres, in your software package you should have this little installation sheet of paper, and what this is reminding you is that our software runs in the 800 by 600 mode, which means you may have to change your monitor setting. Also, you need to have some virtual memory. If you only have 4 meg of memory, you need to make sure that you have enough virtual memory available, and there's a procedure to do that also. I'll walk through that with you briefly right now. Okay, so let's open up the Program Manager if it's not opened already. And then you want to go to your main menu. And in the main menu there should be something called Windows Setup icon. And you want to double click 2 times with your left mouse button. And that will bring up a screen that says Windows Setup, and the very top line says Display. This is the resolution of your monitor, and mine is already set at 800 by 600 by 64,000 colors. You need to have your set, the most common setting is 640 by 480, 256 colors. But you need to have yours set at 800 by 600, and if it's not, you're going to have to change it. But before you change it, let's write down the number that you do have, so in case you experience problems, you can always put it back to where it was. Okay? So if we go up here and say Options, and then it says Change System Settings, and then the top says Display, here's a list of all the drivers we could use to change the resolution of our monitor. And normally what you're going to look for is something that says 800 by 600 by 256 colors. So this is what you should be looking for, something similar to this, which is Super VGA 800 by 600 by 256 colors, small font, and then you're going to select OK, and then it's going to ask you for a driver. If you don't have the driver on your machine, it'll ask you to put it in, and then if you say current, it will then say, do you want to restart Windows and load that new driver? And I'm going to say no, but you're going to want to say yes to get it into the 800 by 600 mode. The second thing that you need to check is your virtual memory. And the way we do that is we go to the control panel and double click on that icon, and that will bring up your control panel choices. And in there you'll find something that looks like a little integrated circuit that says 386 on it. Underneath there it says Enhanced, and what you do is double click on that, and you're going to get another menu that says Enhanced, and one of the buttons is Virtual Memory, and you click on Virtual Memory. It's going to take a couple of seconds now, and then it's going to give you a virtual memory screen. When the virtual memory screen comes up, it will tell you what drive you're using for your virtual memory and the size, whether it's permanent or temporary. It doesn't matter whether it's permanent or temporary, but it does need to be at least 11,700 kilobytes or 11.7 meg. And if it's not, you need to go to set Change, and you'll come down here, and where mine says 20480, you'll need to put at least 11,760. Windows restricts the amount of virtual memory you can set based upon the size of your hard drive and how much space you have available to use for virtual memory, and it also might be restricted based on the amount of RAM you have to access that virtual memory. If you only have 4 meg of RAM and you have a lot of drivers and sound cards loaded, you may have to go back to your AutoExec and config sys file and rem out temporarily some of those drivers to give you enough RAM to access your hard drive. If you do have any problems with your Windows setup to get it to the 800 by 600 mode for your monitor, or if you have any problems with your virtual memory, just call our technical support line. We have technicians ready to help you get your program installed properly. 3D Express has 2-disc installation. There's also several discs of tutorial information that come with the software. Installing 3D Express is just like any other Windows program. You just put disk 1 into your floppy drive. You go to your program manager, click on File, and come down to Run. Click on Run, and then come over to Browse and click on Browse, and then go to Drive A. And you'll see something that says Setup EXE. Double click on that, or click once and say OK, and then that comes up. It says Run that program. You say OK, and that will start your installation process. Before you start any installation process, be sure to close down all your other programs. The install program is going to ask you what drive that you want to install the program on and what subdirectory. The default is C with a subdirectory 3DE, but you can obviously change that. But if that's okay, you just press continue and the program will go ahead and install. I'm going to exit the program because I already have it installed on my machine. Once 3D Express is loaded, you're going to get a 3D Express icon group and a 3D Express icon. And like all Windows program, you just double click the 3D Express icon. When the program loads, you get the 3D Express splash screen and your standard Windows choices, File, Edit, Option, Windows, and Help. Under File, you can open a new project, open a project that exists, close a project, save your project under a different name, add a photo, remove a photo, generate a DXF file, merge DFX files, or exit. Under Edit, we can do some copy and paste. Those are not available right now since we don't have a file open. Under Options, I'll get into that a little bit later, the different modes under Options. And then Windows, we have some other information that we'll get into a little bit later. And then you have your basic help information. Like most Windows programs, in addition to making choices by clicking on under the File or Edit option, you also can do most of those functions through little icons below those selections. And this program is the same. The first icon here is open a new project, open an existing project, and the little picture of the floppy disk is save the project. These are the icons that we use most. This is to load the left and right photograph. The IPS window has 4 little photographs in it, so we represent that with 4 little boxes. Next to that is the calibration target, which is represented by a carpenter square. The one adjacent to that is our 3D box, which represents our 3D viewer. And then next to that is another 3D box, and it says DXF above that. This is where we export our DXF. We also have some features, some advanced features, which you can turn on or turn off by clicking. The X means advanced and the N means normal mode. The advanced features allow us to view the data that we're creating in a spreadsheet form. And we'll get into that a little bit later. But let's go ahead and open up a project to get started. The first thing we're going to want to do is load 2 photographs. And what I'm going to pick is L-Fuser and R-Fuser. And what I actually did was held the Control key down when I clicked the L-Fuser and the R-Fuser. And by doing that, it allows me to load 2 photographs at the same time. So now I'm going to click OK, and I loaded 2 simultaneous. Didn't need to do that. I could have done 1 at a time. And this little box comes up that says these 2 photographs are loaded. We're now ready to go to our IPS window and take a look at the photographs. The IPS window has actually 4 views in it. This is our left photograph, and this is our right photograph. And below the left photograph is our working window, and below the right photograph is a working window for the right photograph. In order to move around in the working window, we have some scroll bars that you can click to move left or right, or move up or down. And we can also zoom in to get a closer look or zoom back to get an overall view. But an easier way to move around the working window is just to click the left mouse button at the area that you want to view in the viewing window, and the working window will automatically move to that point. So if I click over here to the left of the carpenter square, the working window will move there, and if I click over here to this corner, the working window will move to that. Okay? And the right window works just the same. If I click over here in the right window, the bottom working window will move to that position. And this really allows you to move around and to do your work much faster than normal scrolling. Okay, so let's go ahead and start a project now. And when we start a project, the first thing that we have to do is the computer just knows it has two bitmap images, but it doesn't know anything. There's no coordinate system set up for it. So that's what we're going to do to start with, is set up a coordinate system. And by definition, the first point that we click in our working window will become the center of our universe, or 0, 0, 0 in a world coordinate system. And we could click in the center of the picture or anywhere we want, but the most convenient place is right here at the vertex of our carpenter square. So I'm going to click right there, and that will become 0, 0, 0 in a world coordinate system. If you remember your high school algebra, when you used to do charts, if this was 0, 0, 0, then x would be this direction going off to the right, and y would be going up. Well, we're using that same convention. So if that's 0, 0, we're going to say x is this direction. Then if we go this way, that must be minus x. And this is going to be the y direction. And then the z direction is going to come right out of the paper. Okay? So that's the way our world coordinate system is set up. So we're going to go over here and click on the other end of the carpenter square now. And I clicked in the upper window to bring me to the point that I want to click in the bottom window. And now I'm going to left mouse click that point, and that dot appears, and it draws a line from 0, 0 to along my minus x-axis to the end of that carpenter square. Now the next point that I click is going to define an x-y plane, and if I happen to click a point that's 90 degrees from the second point that I clicked, then it's right on the y-axis. So I'm going to tell the computer to move to that point, and I'm going to click right here to make that the y-axis. And now that I've clicked 3 points, what I want to do is close that path, and I'm going to tell the computer draw a line from that point back to the origin again, which it did, and then it prompted me and said, you're right here at 0, 0, 0. Now what the computer wants me to do is define this point in the right view. So I'm going to go up on my view window and tell my working window to come to that point, and I'm going to come down and click right down here at the corner of this carpenter square, and notice the left window jumped over and said, go find the second point that you clicked in the left window, but go find it in the right window. Well, that happens to be up here, so I'll move my working window to that point, and now I'll click at the end there. The left window again prompted me, and this might be difficult to see, and we might be able to zoom in here, but there's a little red line around this dot, and that red line is a little prompt, and it always prompts you in the left view to tell you where to go in the right view. And so I'm going to go over there and find that point in the right view. And now it changed the color of the lines. This closed its path all the way, the right view closed its path automatically to the origin when we click the 3 points. So now we've got 3 points clicked in the left and the right view. We're ready to now do some calibration to help the computer figure out where it is. The first thing the computer wants to know is what was the focal length of the camera. And 50 millimeters is the most common focal length used on 35 millimeter cameras, so we defaulted to that. But this particular picture, we know that we shot it with a 160 millimeter telephoto lens. The second thing the computer wants to know is the units of measure. It doesn't know whether this box is a few inches across or it's the Queen Mary. So we need to give it some information as to the units of measure we want to use. We chose inches because that's most convenient for our project, but you could have chosen meters or centimeters or millimeters or feet. So we'll leave that at inches. The next thing that the computer wants to know is the distance of those lines that we drew. And if we could back out just a second here so I can look at this window, the first point that we clicked was point 1, and we call that A. The second point we clicked was point 2, and we call that B, and the third point we call that C. So it wants to know what was the length of AB, that's from here to there. Well, that's pretty easy because this is a carpenter square and we knew that was 24 inches. And so we're going to put 24 inches here. The next thing it wants to know is what's the distance from A to C. And again, we know that that's 16 inches. But if we didn't, we would have had to measure something here. We would have had to measure the bricks, or we could have measured something on the object itself. But we do have to know all of these measurements. So we're going to put 16 inches there. And then the third thing it wants to know is what is the length of the hypotenuse of this triangle. And if we didn't know what that was, but we knew it was a right angle, we can let the computer calculate that for us. And so now we've done everything that the computer needs to know to calibrate the photographs. Okay, so now that we've calibrated these photographs for the computer, we can now go ahead and build our object. But before we do that, let's just take a look at our 3D viewer to see what our calibration target looked like. And what it did was it drew us this little triangle. Now it's a little bit at a little different perspective, and maybe if I move around here it'll look a little more like the way it should. But this is the line from the origin. Here's the origin here. And we went over this way. You can see it went over 3 units, that's 24 inches, and it went back 2 units, that's 16 inches. Okay, so it went back that way. Now, our little viewer, we can spin all the way around and look at it from any angle that we want to. We can look at it from the top. You know, not too interesting. Let's go on and build a face here. So the first thing I want to do is just build this front face. And what I'm going to do is just to click 4 corners on the front of this face. So I'm going to click 1, 2, I'm going to come over here, 3, and 4, and then I'm going to close that face. And now I've built this front face. Now for those of you that have done 3D design before or had any drafting classes, you're probably going to say, you know, actually this should have gone down here and over there and up here, and you're absolutely correct. That's the way we should have built it. I'm just kind of lazy, but I want to show you there's some advantage to our software, and I want to show that to you a little bit later. So we're gonna do a shortcut right now. Okay? So once we click these 3 points and close the face, the bottom corner here got a red line around it and prompted us to go find that point in the right view. And so that's what we're going to do. We're going to go find this point in the right view. So I'm going to go click here at the upper window, and that's going to move the bottom window to that point. Now I'm going to click on that point. Again, I'm doing all this with my left mouse button. So the computer is going to prompt me to go find the point above that. So we'll go over to the right and we'll do that. And now the computer is prompting me to go find this left-hand corner. So we'll get the right view to move over there. We'll click that point. And now it's prompting me to go find this bottom point. So I'll go find that. And now it turned the lines yellow and it closed those paths. And it says I've done this front face. And now we can go to the 3D viewer and view this project as we do it. Now we're from the top view, so that's just a line. But if we look at it from the front, there's that front face. And then if we actually click in this window, we can use our scroll keys, our left, right, up, and down arrows, and we can spin around it and take a look at it from any angle. Okay. Let me get out of there for a second. Let's go on and build a little more of this fuser box. So let's go back to the upper left-hand corner, and we'll continue on. What we're going to want to do is build this face. And as we do that, we're going to click a point right here. Well, we already know where that point is, so we're going to hold our control key down, and my cursor changes to indicate that this is going to be a shared point. And when I click on that point, it's going to give me a new point, but the new point is going to have the exact same location as the existing point. That'll assure that that corner of that box comes together properly. The next point that we're going to click is right here at the top of the center of the box. And then we'll click the backhand corner, and then we'll click the bottom. And then we'll come back to the front, and we want to share that point again, so I'll hold the control key down again and then click it. And now we have shared that point, and now what I want to do is close that path, and it's going to draw a line back to the origin there for me. And now notice the left window. This might be hard to see, but it's actually prompting me to go find this point in the right window, not the first one I clicked. See the red around that dot? And the reason is that it already knows where this point is, because that was a shared point in the front face. So it's telling me go find that point. So we'll go over here, and in the upper right window we'll click on that, and that'll bring that up here for me so I can find it in the lower window. And now the computer is telling me go find that back corner, and I'll find the back top corner. Then it says okay, go find the back bottom corner. So I'll come over, I have to click on the top one here to move it. Now I'll click in the bottom right corner, and now the lines all changed to yellow. It's found that, and now we can go take a look and see the computer. Sure enough, it has drawn this side, and we can spin around and look at that side, or if we want, we can look at the right side, and it'll give us a nice square view. I think that you could see that pretty quickly we could draw the rest of this box, and I think the record in our office is about 5 minutes. If any of you have done any AutoCAD type drawing or created things with other kinds of programs, you know that first you would have to make all the measurements of all these dimensions of the box. You'd have to set up your scale factor. You would have to, it could take you quite a while to draw just a simple little box to get ready to do that. So what 3D Express does is it allows us to create three-dimensional drawings by just kind of tracing the outline of that drawing in a left and a right view. Now obviously you're going to have to take more than 2 photographs to create a full three-dimensional object because you can't see the back of this box. But this program will allow you to create 3D objects probably much faster than any other program that's on the market today. But that's just the cake. The icing is that since we build the object from a photograph, we've figured out how to take the pixels off the photograph and stick them back onto the object, so we really get a three-dimensional photograph. Okay? But before I can show you how we do that, what I have to do is to break up these surfaces into 3-point surfaces. And the reason that I have to do that is that the animation programs that we deal with today can only render 3-point surfaces because they can't render something that's round. In other words, if it's rounded, you can't put a color on something that's round. It's just a limitation of the computers today. So what I have to do is to make sure that I have flat surfaces. And the way all animation programs work is they represent round surfaces by a whole lot of little triangles. It's kind of like the geodesic dome that are built with triangles, and when you make the triangle small enough or you get far enough away, it looks round, but it's really triangles. So let me just take a second and break this side up into a bunch of little triangles. And the way I'm going to do that is really simply, I'm just going to hold down my control key, which is my share key, and I'm going to click on 3 points. And then I'm going to say close face, and that will build that little triangle there. And it does it on both sides because it knows where all those points are. Now I'm going to do the same thing for 3 points right next to that, and we'll say close face, and do it one more time here. And it doesn't really matter which order I click them or how I click them. I just have to break it up into little triangles. And one more here. Come down here, close face. Okay, now let's take a look at our little 3D viewer. And now you can see that it's got triangles there. Let me just turn off the grid and the calibration target for a minute. Okay, so here's our 3D drawing, and here's our photograph. And so what we do is we cut this photograph up. And if you'll notice over here, right on my IPS window, there is the X and Y location of point 4. And I can get information about any one of the points by holding my Control and Shift key down and clicking on that point, and up above here will tell me the point number that it is in my database. It'll also give me the X and the Y location, and we measure that information from the left top corner. So it's over 582 pixels, and that point came down 346 pixels. Okay. Below our controls here is actually the X, the Y, and the Z location of that point. And as example, X happens to be minus 1.535 inches. And here is 0, 0, 0. That's the minus X direction, so we're over minus 1.53 inches. It also says that Y is 2.007, so it says that we're back on the Y direction, 2.007. The Z distance is 4.212, and that would be up, so that's 4 inches above that ruler. Okay, so that's the way we measure the XYZ data. There's the XY data of the photograph, and so since I know the XY data and the XYZ data for each photograph, I can cut this photograph up into a little triangle. I say I want the photographic information in this triangle right here always to fit on my 3D wireframe in this triangle. Now this triangle may get smaller or bigger depending upon how I rotate it, or it may actually even go out of view. Okay, so let me create a quick view of this, and I'm going to click View up here, and it says Quick Look, and there's our three-dimensional quick look of that box, and it looks pretty realistic. I mean, it looks just like the box because in fact it is the box. The photograph has been cut up to match the wireframe. Now remember earlier when I said that when we built this front, we technically should have come over here and gone down and over again and back up, and I said I'm just going to take the lazy man and go right across the top. It's because what we find in a lot of our modeling is that we don't have to put a lot of the detail and create a lot of the little triangles or polygons that you would normally do if you were going to do this in some kind of AutoCAD program, because the photograph picks up all that detail for us, and it kind of fools us in thinking that it's actually there. We have that same phenomena here on the side. Look at all of the vents. Normally if you wanted to see those vents, you would have to draw each one of those vents on your object in order to get that kind of representation in your three-dimensional model. 3D Express is not an animation program, but we can kind of simulate what an animation program does, and really all it does is save out a series of files from different views. We can simulate that by just rotating the object one frame at a time. And so if we wanted to simulate an animation using Quick Look, what we would do is we would pick a particular angle, save out a view, then what we do is we would go up and save that and give it a file name. I'm not going to do that now. You could then move the object a little bit and create another view from a slightly different angle and save that file out. And by going through a sequence of these, you could create an animation. Actually, full-blown animation programs have got a lot of other features in that they can set lights and a stage and move the camera and the object and the lighting around dynamically and morph and warp and do a lot of much more exotic things. They say this is not an animation program, but you can get a good idea of what your object's going to look like by this Quick Look feature. This Quick Look feature has really not been released yet. It will be released in our next version of the software. If you don't have it in your version, we'll be happy to send it to you free of charge so that you can inspect your objects as you're building them and see what they're going to look like with the photo texture map on it. Okay. When we first started, we talked about that there was a spreadsheet of database, and I'd like to just kind of review that with you briefly. And this is the spreadsheet, and you'll notice that it's just a listing of points and their X, Y, Z locations and the length between the two adjacent points. Remember when we clicked point 1, we decided that was going to be 0, 0, 0 of our world coordinate system, and that's why this is showing 0, 0, 0. So point 1 was 0, 0, 0. And remember point 2 we decided was 24 inches in the minus X direction. Well, I was a little bit off when I clicked that point. And then the Y and the Z was 0, 0. And so each point that we add to the database has a definite X, Y, and Z location assigned to it. We can move any of these points in our image point selection window, our IPS window, image point selection, that's our IPS window, we can move any of the points in our image point selection window, or we can move them by changing the number in our database. To move it on the image point selection window, we hold the shift key down and we get these arrow keys. You put that over the point that you want to move. Put the arrow keys over the point you want to move and click your left mouse button, and it will highlight that point. And then what you use is the number 4, 6, 2, and 8 keys on your numlock, and you have to have your numlocks on, and then you can move that point left or right, up or down, a point at a time. And then once you get it to the point where you want to keep it, what you do is you hit the number 5 on the numlock, and that will turn that function off. If you forget to do that, weird things will happen to you. So please remember to turn that move function off before you proceed. And I say the other way that you can move that point around is you can go to the database, and you could go to database and say, I don't want this to be minus 1.535, I want it to be minus 1.60, and in fact that's what it'll be. So those are the ways that you can move the points around in the IPS window or in the spreadsheet. While I have the spreadsheet open, there's a couple other features that I'd like to just point out to you. One of them is what we call the auto calculate, and when you first start a project you might want that on when you're doing boxes, that's fine, but the auto calculate is going to automatically move things around based upon a snap to, which is an adjust tolerance you set up in this window, and that's a nice way to make nice square boxes if you use the snap to, but normally you're not going to want the computer to do that for you, so I would leave the auto calculate off. I would turn that off when I first start to build my 3D object. A couple of other features that I'd like to show you here before we go is if you go up into the options, we have some preference modes, and one of them is our user mode, and that's the expert or the normal. If we put it in the normal, we lose control to get into our XYZ database, but no problem, you can always just hit this N button, that'll bring it back for you. The next is your IPS preferences, and you can change the point size, 4 being the largest, 1 being the smallest, both, and you can also change their colors if you want to change that. You can also change the camera format, and we have set this for a 35mm camera. You can use video cameras and digital cameras, but we suggest that you leave it in the full frame 35mm mode, and if you want to use some other camera, call the company or we'll send you some information on how to calibrate your camera to use those other types of cameras. The other thing here is the IPS repaint, and if we put that on, it will redraw all of these windows here. I usually like to leave it off because it runs a little faster. Our photo list just shows us what left and right image that we have loaded here. The name of the photos in our left and right view are also shown right down here at the bottom of the photo. So there's the name of the left photo, and there's the name of the right photo. Our image point selection, that's the window we're in, our image point selection, or IPS window. Our points database, this is another database of the points on the photograph. Okay? This is not our XYZ database of the three-dimensional data. This tells us where point 1 is on the X and Y location on the photograph itself. These are in pixels, and point 1 is 607 pixels from the left top corner over this way, and it's down 473 pixels this way. And so each point in our database will have a pixel 1 X and Y location, and that's for the left window, and then P2X and P2Y is where that point is located in the right window. And in some cases you may want to move them around in this database instead of moving around manually. We'll get into that with a lot more detail in our training materials. Our path database tells us how these points are connected together. Remember, I connected point 1, point 2, and point 3 into a path, and you notice that we've got point 1, point 2, and point 3 connected as a path, and they're called a closed path. Okay? If I go to the next path, remember that I clicked point 4, point 5, point 6, and point 7. So there's point 4, 5, 6, and 7 all connected as path 2. And if I go to the next path, remember we started and we connected along the right side over here. Whoops. Remember we connected along the right side over here for 5, 8, 9, 10, back to 4 again. And that's the way that path was connected. So this keeps track of your path information, and as you get into more complicated models, you're going to want to be able to use this and find out how you connected things up. There will be times when you're going to want to use this. But normally, for simple projects, you don't use any of that. You just trace the outline of an object in the left view and find the same points in the right view. The XYZ data, that's our spreadsheet, which can also be reached through this little icon right there. Our wireframe viewer just shows our wireframe again. And this is a little spreadsheet that you can use just to store information in. One of the other things that you can do is you can go to your database and you can come here and you can actually hold the mouse down just like you can in Lotus or Excel, and you can grab a bunch of points, you know, one or more points, and you can use the Control-C for copy, and then you can go over to this little database over here someplace and you can use the Control-V for paste. So you could take your points from your database and stick them over there as a little scratch pad database for you. You could make some modifications over here, and then if they didn't work out, you could always grab that data and come back over here and copy it back over on top using Control-V, and copy that data back over on top here if you wanted to do that. Some people are actually taking things like wheels and tubes and things like that, and they're actually building them in Lotus spreadsheets or Excel spreadsheets, and then just bringing those points, copying those points into our database makes it much easier and quicker than trying to make a round circle. And we'll go through that a little bit more with you in our training program. So that's kind of the basic functions of 3D Express. What I suggest you do is to try to put the videotape someplace close where you can see it and load the program, and try to follow this on your computer while you have your videotape running. And then if you need to, just pause the videotape while you follow the same things that I'm doing here. It's probably the easiest way to do this, and it saves you a lot of time. Most people don't like to read manuals, and so this is an easy way to get you up and running on the program. Third Dimension Technologies has a goal of creating 20,000 3D wireframes in the next several years, and we need a lot of help. If you can build this fuser box, and this is something you think you might want to do, we would certainly invite you to become a subcontractor and to build 3D objects for us. And included in your software should be some information on how you can work with us as a subcontractor. Again, if you have any questions, just call one of the telephone numbers in the information you received. Thank you. So what we're looking for is to put together a collection of people that want to become a 3D artist, okay, without the necessity of having to spend years at going to art school or AutoCAD school. Does not mean we're going to show you how to do this simply. Does not mean this is simple. Okay, this is not simple. This is going to take you several weeks to learn, and it's a learning curve. but it's not like learning AutoCAD or something like that. What I'd like to do now is show you how you can make some money doing this and kind of go through our contract. If you kind of have that handy. If you'll notice on the first page, it says that the very first paragraph, it says that you're a subcontractor. You're not an employee or an officer or anything of our company. So the money that you receive would be 1099 income. And that makes you like self-employed, is basically what that's saying. Okay. The other thing is that this is not for beginners. Okay, if you just bought a computer last week, this is definitely not for you. You need to understand how Windows works. You don't have to be an AutoCAD guy, but we will give you some assistance to help you learn the program and get it running. But we just don't have the ability or the manpower to help you learn Windows if you don't understand that much about the computer. You're going to have to do that on your own. Okay. If you come down here where it says categories of wireframes, the things that we actually want right here on the first page, you'll see the first thing is all 1996 automobiles. They just came out. Obviously we want them. 1995 automobiles. Sports cars, hot rods, classic cars, race cars, any animal, fish or bird, military vehicles, military weapons, that's obvious for games and stuff, airplanes, trains or boats. Pretty much if it moves, we want it for our collection. Musical instruments, we showed you the first one that we've gotten in the door now. We want a full band complement. We want furniture, but we want high quality furniture. If any of you have seen architectural fly-throughs, that architects draw these buildings, they ask people to give them millions of dollars for architectural engineering fees, and so the client wants to see what's it going to look like when you're done, or show me something you've already done. And as they're doing some of that stuff, they get paid for drawing the buildings, but a room looks kind of stark and you can't get any idea of dimensions unless you stick some furniture in. So what most of these fly-throughs do is they stick some furniture in, but the furniture they stick in is like stick furniture and whatever, really low quality. So what we envision is having a CD-ROM just for architects of furniture. But we want, overstuffed couches. We want, executive conference tables. We don't necessarily want little stackable chairs. We want nice quality things that people would be delighted to add to their presentation and make it look better. Okay. Human parts. Obviously, there's a lot of medical applications. We want people, like men, women, and children. We also want organs. We don't want you to cut anybody out. But there is a lot of sources for that information. A lot of the museums have models of organs. A lot of doctors' offices. Actually, one of the people I talked to from some university back there, he's got cadavers that they're actually doing stuff with. So there are sources, but we've got a lot of different categories. What's good for one person might not be good for something else. But at this point, we want everything because we have practically nothing. And so we just kind of, instead of us telling you what we want you to do, we're kind of saying, here's the general categories. You pick out what's the most convenient and easiest for you you have access to. Buildings, we want buildings, but we just don't want your house. We want major buildings, things that people would recognize, like the Eiffel Tower, or the Empire State Building, or things like that. LA City Hall, O.J. Simpson's house. So we want things like that. But we also do want neat architectural things. So I mean, if you live someplace where there's some antique house next door, or there's somebody who's got some building and you think architecturally it's kind of unusual or different or interesting, then take a photograph and send it in to us. Say, hey, what do you think? Would you do this? I'll do it for $300 or $500, and we'll get back to you in a few days and say, yeah, go ahead and make it. We'll take it. Okay. Obviously, any statue that like Mount Rushmore or whatever. And interior space, and I need to double stress this more because we're not getting much of this, but interior space is really just walls and rooms, okay? And they're very simple to do. They're like doing a box on the inside, okay? Yet, if you did that wall, you click 4 corners and then cut it in half, you get not only the wall, you get the light switches, you get the things that are on the wall, you get the texture of the wall, you get the little wood that's on the bottom part of the wall. So we get a tremendous amount of detail, and we can take just that wall and stick it with this window wall or some other wall and just line them up and build rooms real easy. So we really want a lot of that stuff, and certainly we encourage you to do that because we don't have much right now. At this point in time, you are responsible for the total project. In other words, we ask you to take the photographs and scan the photographs, build the objects, and deliver us, a completed wireframe. Okay, it's not as difficult as you might think, and we have our basic training class will go through on how you take the photographs and set up your project and how to get them scanned. You don't need a scanner. Scanners cost $400 or $500. You can certainly, if you buy one, that's fine. But there are scanning services that will put these onto CD-ROMs, which what we prefer. When they put them on CD-ROMs, they charge you about $1 to $1.50 a picture. Okay, and we actually want you to do that. And if you put them on, you'll find in one of the other paragraphs of our contract, we will pay you $20 per project to put them on a CD-ROM, because we want those high-quality images and we want them archived anyway. So if you give us a physical photograph or a negative with your project, we're going to put it on CD-ROM anyway. So we say we'll pay you to do that. Okay, and if you put 5 of them on one CD-ROM, that's $100. That's more than you're going to pay for that CD-ROM. Okay. If you go to the second page, we talk about pre-packaged projects. And we're not there yet, but we have people working on this. And the way this is going to work is there's two groups. The first group is pre-packaged objects, which is contract work that one of our offices brings in. And say if we get this major contract with studio, we're going to send photographers down there and shoot several thousand objects. And we're then going to package those objects and put them up onto the bulletin board or up onto the internet. And if you're one of our subcontractors, you will be able to download that and build that project and then upload the completed project back to us again. Okay? On those projects, we will set the price as to what we will pay you to do that. Okay? On projects that you do from the start, you set your own price, and you set your price based upon the samples that we're giving you here. Now, these are not our wireframes. This happens to be a competitor. They're one of the largest and they're the best. They are the best in the world today. And what we've done is taken their retail price list. If you wanted to buy one of these from them, as an example, let's go over here to this Dodge Viper. You all find this Dodge Viper? Okay. If you wanted to buy that Dodge Viper from them, they would sell it to you for $600. Okay, so we just took their price list and their catalog, which they send out to anybody. You can get one yourself, and we just took their price list and said, if you make us something comparable to their Dodge Viper, we will pay you what it would cost us to buy it, $600. The only difference is the one you make for us is going to have a photo texture map with it. Okay? And we're not going to sell it for $600. We're going to sell it for $1 or $2. But we're going to put 100 of them on a CD-ROM and sell it for maybe $100. Okay? So next year, instead of giving them $600 to buy a Dodge Viper, you'll be able to give us $100, and we'll give you 100 Dodge Vipers. Okay? With photo texture maps. Okay? So that's the kind of savings we're talking about and why we think we're going to be so successful at putting out our project. Okay? Now you'll also notice over here we've got another vehicle, and it's called a Fiat, and their price on that is only $250. Okay? Well, the difference is the Fiat doesn't have as many vertices. It's a much simpler drawing. Okay? But we actually want both of them. This is a higher quality drawing, and if we wanted to zoom in real close on it, this is going to look much better than this one. But if you wanted to move this around quickly and render it from different views, if this was in a game and you were going to move it around quickly, we wanted to redraw that 20 or 30 times a second, okay? We could redraw that 30 times a second, put a texture map on it, much easier than we could draw this 30 times a second. Okay? So the people that are going to buy these objects from us to put them in games, in many cases they want this detail. So we want both details. We want a high detail and we want a low detail. Okay? And if you want to, if you're going to build a car, you can build one to the low detail and one to the high detail, and we'll buy both of them from you. We're not going to pay you full price from both because we know that you're getting double duty out of those photographs. But we will pay you the full amount for the $600 for the high detail, and we'll pay you half of whatever the low detail was. So if you give us two of them with the same set of photographs, we'll pay you $600 plus $125. Okay. But the way our program works is that you decide what you want to make, and let's say that you have got some trains and you want to make a train. Okay? So you pick a train and you decide you've got a locomotive, and you look in here and you say, gee, I could build something similar to that. So you say, my name is Bill Smith. I want to make a locomotive similar to this steam engine here, okay? And I want $500 for it, okay? And what you do is you create an item on our bulletin board, and soon to be on the internet, but for now you have to call our local electronic bulletin board, a BBS system, and you reserve a train. Now before you do that, you look to make sure nobody else has got a train with the same model of whatever that you're doing, okay? But if nobody else has done that, then you reserve it, and you have 30 days then to complete that project, and you put the price that you want. Now if you use the prices based upon the samples we've given you here, or the catalog of this other company, okay, we will pretty much go, we're in agreement. Okay. Now, if you say I'm going to do a Viper and I want $600 for it, and then what we get is something that looks like that, we're going to call you back and say we don't think that's worth $600. That looks more like a $200 thing to us. So, but what you want to do is tell us, compare what you want to build to one of the samples in here, whether it's a vehicle, whether it's an animal, whatever it is. You use this as a sample to guide you in the price that you want for your piece of artwork. Okay? Once you complete that, once you decide what you want to do and you upload it, we will then put a message on the bulletin board within a few days. Sometimes we're running a week or so behind. But we will then answer you with an email and say, your project to do this car is accepted for $500 or whatever. Okay? So that's the way we kind of work. Okay? You then go ahead, take your photographs, complete that project. When you're done with it, you can upload it either to the internet or up to our bulletin board. Okay? And then we review it, make sure that it in fact looks like a car. Okay? It doesn't have to be necessarily per scale. We're not going to make engineering drawings from this. But if you say that I'm making a Dodge Viper and it looks, like a Pontiac, or the texture map doesn't fit, okay, then we're going to kick it back to you and say, you got to do some more work before we're going to buy it.
But is there a market for to make nerves and bricks for the engineering study of the bridge or something like that?
Sure, absolutely. Anything that an architect might want to put into some kind of a presentation, we would be interested in. And I mean, just think of yourself that if you were drawing a drawing or had a three-dimensional fly-through of a building, and you don't want that building to be empty. You're going to want to put some shrubs in the front of it. You may want to put some potted plants around it. You're going to want to put something in the lobby. You're going to want to put some desks and some chairs. And so pretty much anything like that we're interested in. You may want to give us some small, object-like bricks or concrete blocks and stuff. We're not too terribly excited about just a block, because I mean, you can make something like that pretty quick just in any kind of a drawing program. But if it's on the list here of these things we want, okay, if it's not on the list, it doesn't mean we don't want it. You're just going to have to coordinate that with somebody in our company as to what it is you're going to do and how much we're going to pay you for it. Okay?
So basically, Ray, you're saying all things are negotiable?
Correct. Sure. If you go to the third page, where we're talking about, I'll go to paragraph 15, the bottom. This is where we talk about if through your friends or where you work now, you're able to find a company or a person that wants to have 25 or more of their pieces of things, their products, their widgets, converted into three-dimensional objects and put into some kind of a presentation or put up on the internet, or they want a multimedia presentation of their products. We have people, subcontractors, that have those capabilities. Okay? And if you bring that contract to us, we will pay you 10%. Now, our minimum price to build a three-dimensional object is going to be like $1,200. Okay? So we don't really want, for corporate-wise, to get involved with anything less than about 25 objects. So if you take 25 objects times $1,200, that's a $30,000 contract. Your commission on that would be $3,000. So that's kind of like a minimum. If somebody wants 5 or 10 objects done, you just go do that yourself. You go get your own contract, you build it for them, you can do that in a month or two. Okay? But if you have somebody that has 25 objects or 50 objects or 300 objects that they want to make, or if they want to turn those objects into a multimedia presentation so they can hand out CD-ROMs, or if they're interested in putting their product or service up on the internet so they have their own presence on the internet and people can look at them and view them, then you want to bring that to our company, and you're going to get 10% of whatever that contract is. Okay? You'll also get the opportunity to work on that project, naturally, because you're the one that helped bring it in. Okay? And the overflow and the things that you're not capable of, which is probably, authoring a CD-ROM or building a website, we have other of our subcontractors that have those talents, and we'll pick amongst the other subcontractors, and we'll divvy up all that work between everybody else. We virtually have got dozens of animators working for us now that come in. We have dozens of AutoCADs. We have several of our office managers are architects. Several of them are professional animators. We have people that author CD-ROMs. We have a lot of people that have built websites, including myself. So we have a lot of talents, and every time, I don't even know what you guys do, but everybody is bringing more talent to the party. Okay, and so we're really in a very unique position that we can do anything as far as graphic presentations that somebody wants. And all we're saying is that if you happen to bump into something like that, or you happen to mention to somebody at your job that, gee, you're a subcontractor for this company, a company has all these great technologies and capabilities, and you help bring it, you could make money by bringing those projects in, as well as getting more work for yourself. The other thing that we also need is technical support people. Okay, and what any of you that have called Microsoft or any company for technical support have probably been as frustrated as I have, and you'll find that they put you on hold for an hour or two, and then you get through to somebody and he tells you to call somebody else. Okay, and we've got the same problem. I can't say that we don't, because we're growing very rapidly. But what we envision is a way to cure that problem. And the way that we're curing that problem, or plan to cure that problem, is to take some of our subcontractors that are making wireframes for us out of their home anyway, and working out with them the ability to have office hours at the home, if you will. And so when technical calls come in here and we can't handle the calls because we're already talking to somebody else, we're going to say, we're going to take them and refer them to some subcontractor in their area that has already built a wireframe that we know that can answer technical questions, and we will refer those calls to you, and you can take those technical calls in your home. Okay? And so that's how we envision to have a lot of people to do that. And once you have delivered a wireframe and we know that you can do that, you can be asked to be put on our technical support call list, and you can give us hours that you're available, that you're willing to take calls, and if somebody calls us and we can't handle the call, we will in fact forward it to you, and you can handle that call, and you will keep a log of the calls that we give you, and you will be paid at the end of the month for all the calls that you handle on a call-by-call basis. Okay, and so this explains how that's going to work in our program. But if this is something that you would like to do, what we'd like you to do is to send back our contract, sign it here, which makes you a subcontractor, pay us $200 for our training. You can put it on your charge card or include a check. Give us the information of what you want, how you're going to log onto our bulletin board so you can make reservations for your projects. and send this back with $200. You would then be a subcontractor for us, and we will then send you our video training tape program to help you get started making money in the 3D graphics industry. Thank you.